Yellowstone National Park's calm appearance belies an ongoing symphony of tremors. Known for its geysers and natural beauty, this iconic landscape is in the midst of an exciting yet enigmatic geological drama. In recent times, hundreds of earthquakes have struck Yellowstone, each adding a new piece to the complex puzzle of seismic activity in the park. These tremors invite us to explore the secrets hidden beneath Yellowstone's surface and reveal the truth they tell us. Get ready for a fascinating journey into the depths of the Earth's crust and discover the secret life of this captivating landscape. What is Yellowstone and why is it special? Yellowstone National Park, located in Wyoming, Montana, and Idaho, is a vast natural refuge spanning 2.2 million acres. In addition to its abundant flora and fauna, what makes Yellowstone special is its unique geological heritage. It is home to one of the largest active volcanic systems in the world, with a wide variety of geysers, hot springs, and fumaroles. But most impressive is the dormant supervolcano that lies beneath the park, evidenced by the Yellowstone caldera, a huge depression formed by a past volcanic eruption. This supervolcano has captivated the imagination of scientists and tourists for its catastrophic potential. Yellowstone National Park, established in 1872, is a unique place in the world. Its impressive geology, abundant wildlife, and rich cultural history make it a favorite destination for nature lovers and explorers. Yellowstone's caldera, a scar from a past cataclysmic eruption, is a reminder of the powerful forces that shape the landscape. In addition to its physical beauty, the park has a cultural history rooted in the Native American tribes that have called the region home for thousands of years. Historic sites throughout the park tell the stories of these communities and their deep bond to the land. Yellowstone is a place where natural wonder and cultural heritage are extraordinarily intertwined. Yellowstone's cultural richness was enriched by the arrival of European explorers and settlers in the 19th century, leaving their mark on the park's historic structures. In addition to its importance as a world leader in ecosystem conservation, Yellowstone captivates with its biodiversity and geological wonders. This park is a living microcosm of Earth's evolutionary history, where human curiosity meets the mysteries of nature. Each aspect of Yellowstone tells a unique story that invites us to explore and understand its magic, revealing the secrets of seismic activity. Yellowstone's seismic activity is part of this natural phenomenon. The park is located in a geologically active region, where tectonic plates meet and move slowly. As a result, periodic earthquakes occur in the area. These tremors, while they may seem alarming, are a manifestation of the underground dynamics of the park and do not necessarily indicate imminent danger. Scientists and experts closely monitor these events to better understand the geology of the area and assess any potential risk. Although seismic activity may arouse curiosity and concern, it is important to remember that it is part of the natural cycle of our planet, and that measures are taken to ensure the safety of visitors and the preservation of the park. The earthquakes are a direct result of seismic and geothermal activity fueled by the powerful hot spot that feeds the park's supervolcano. These tremors are valuable to scientists, as they provide information about the structure and composition of the Earth's crust. Using measurement scales such as the Richter and Mercalli, experts can assess the magnitude and intensity of earthquakes, allowing them to better understand the geological processes at play. Through these events, Yellowstone's subterranean enigma is revealed and deeper insights into our planet are gained. Seismic activity at Yellowstone is a regular part of its geothermal dynamics. Scientists have discovered a magma reservoir and an underground magma chamber by analyzing seismic waves generated by earthquakes. Although the park experiences hundreds to thousands of earthquakes a year, most are small and go unnoticed. Seismic swarms, rapid sequences of tremors in the same location, raise speculation but have not caused volcanic eruptions in the past. Geologists and seismologists are studying these swarms to better understand the dynamic nature of the Earth. Each tremor contributes to Yellowstone's geological tapestry, telling the story of our planet. Let's keep exploring the seismic secrets that Yellowstone reveals to us. Recent seismic swarms in Yellowstone. An unprecedented seismic concert has been taking place in Yellowstone. Seismic swarms, a series of small earthquakes originating from the same location, have intrigued geologists and visitors. These swarms reveal a disturbing activity under the apparent tranquility of the park. The Yellowstone hot spot, with its active magma plumes, has triggered this increase in seismic activity, creating a tremor ripple effect throughout the park. Recently, an earthquake swarm in Yellowstone has attracted attention due to the amount and persistence of the tremors. Although they have not caused major surface damage, some have reached significant magnitudes, enough to cause vibrations in windows and on the ground. What makes this swarm particularly interesting is its concentration around the largest geyser in the park, Steamboat, and its shallower depth compared to previous swarms. This closeness to the surface and the intensification of the geyser's activity have led to questions and speculation about the possibility of a Yellowstone supervolcano eruption. Given the park's volcanic past, it is not surprising that these tremors have raised concerns. Seismic swarms at Yellowstone do not always indicate an imminent eruption of the supervolcano. These events are common and are related to the movement of fluids and gases in the subsoil. Although they can affect surface geothermal activities, they are not usually associated with the deep magmatic processes that precede volcanic eruptions. Despite the intensity of the tremors, no significant changes in the magma deposit or in the deformation of the terrain have been observed. Seismic swarms are a manifestation of the park's geothermal systems, driven by movements of fluids in the subsurface. It is an opportunity to study the geology of the park and gain valuable insight into the hidden processes that shape this geothermally active region. The potential impact: a nightmare or an exaggerated concern? The Yellowstone earthquake swarm has raised concerns due to its association with the park's dormant supervolcano and its potential for a catastrophic eruption. Supervolcanic eruptions are powerful events that can change the global climate and reshape landscapes. Yellowstone has experienced 3 such eruptions in the past 2.1 million years, spewing enormous amounts of ash and lava. Although the possibility of a future eruption is uncertain, the impact of such an event would be devastating. The Yellowstone supervolcano last erupted about 640,000 years ago, creating the present-day Yellowstone caldera, a large volcanic crater. A similar eruption today would have devastating consequences, including blanketing large areas of the United States with ash, causing infrastructure disruptions and damaging agriculture. Additionally, the release of large amounts of sulfur dioxide into the atmosphere could lower global temperatures, potentially triggering global cooling. However, supervolcanic eruptions at Yellowstone are rare events, with thousands of years in between. Also, recent volcanic activity has been mainly non-explosive. Therefore, the probability of a supervolcanic eruption at Yellowstone in the near future is extremely low based on current scientific consensus and monitoring data. Although seismic activity has increased at Yellowstone, there is no evidence of an imminent eruption of the supervolcano. Most of the tremors are related to hydrothermal activity, rather than subterranean magma. However, it is important to exercise caution and be prepared for potential local hazards such as minor volcanic eruptions, hydrothermal explosions, and landslides. Seismic and geothermal activity in the park must be closely monitored to reduce these risks. Although a catastrophic eruption is unlikely, we must balance scientific discovery with responsible risk management and maintain a respect for the power of nature.